Hello, Algebra 1 students. Today's lesson we are going to be working on how to multiply polynomials. So in order to understand how multiplication works, I think it's important for us to kind of hone in on our previous skills. So I think in combining like terms and adding and subtracting polynomials, we should have already established what 2x plus 3x is. So 2x's plus 3x's, we add the 2 and the 3 together, and that makes 5x's. So 2x plus 3x is 5x. All right, but how does that work when we take 2x times 3x? To understand how to multiply, I think it's important for us to think about what we know about x squared. You should have learned before that when you take something and raise it to a power, that just means repeated multiplication. So in other words, x squared means x times x 2 times. X cubed would mean x times x times x 3 times. Okay, with that in mind, let's go back to what would 2x times 3x be. Those are both considered polynomials. They're single terms, so they're monomials. So when we multiply this monomial by this monomial, okay, I'm going to actually rearrange it slightly to make it easier to understand. Because this is multiplication, we can change the order around. So rather than writing this as 2x times 3x, I'm going to rewrite this as 2 times 3 times x times x. And I think when we write it like that, it makes it easier to understand that we are multiplying the 2 and the 3, so that's going to give us 6. And then x times x is really just x squared, because that's 2 x's being multiplied. So that's 6x squared. Okay, then let's see how that plays out when we start doing more complicated examples. For example, what if I wanted to distribute x squared to this quantity x cubed plus 5 and then subtract 2x squared? That's going to take a lot of different parts to it. So first, we're going to distribute the x squared. Remember that distributing is the same thing as multiplication. So this is like doing x squared times x cubed plus x squared times 5, and then minus 2x squared. All right, let's clean this up a little bit. X squared times x cubed, if I write that out, that's like writing x times x 2 times for x squared, and then for x cubed, I'm multiplying by x 3 times. All together, I have 1, 2, 3, 4, 5 x's. So this can be just written as x to the 5th power. So x squared times x cubed is just x to the 5th power. Some of you will notice really quickly that all we had to do was add those exponents. When we multiply two variables together, we can just, if they're the same variable, we can just add the exponents on them. All right, and then that's x to the 5th plus x to the 5th times x to the 5th, or, oh, whoops, that was supposed to be an x squared, whoopsies, right? It was x squared times 5. So x squared times 5, I'm going to rewrite that where the number comes in front. So it's just 5x squared. And then I'm going to bring down the minus 2x squared. There's no extra math there. Last but not least, we need to combine like terms. So I see an x squared term and an x squared term. When I do 5x squared minus 2x squared, I bring down the x to the 5th here. 5x squared minus 2x squared is 5 minus 2. So that's positive 3. And then they're like terms, so I just bring down that x squared. So just to kind of reiterate, when we multiplied x squared times x cubed, we ended up getting x to the 5th. We also have a coefficient in front of that x to the 5th, which is 1. The 1 is because we multiplied 1x squared by 1x cubed, and 1 times 1 is 1. So when we multiply, we want to make sure that we multiply the coefficients and then we add the exponents. All right, let's try that with a little bit more complicated of an example. Let's move down to example 4 here. Okay, this I'm taking negative 2xy cubed minus 6x squared, and that quantity is being multiplied by 3x to the 5th. So this is a little bit weird because we're doing backwards distribution, which is totally fine. It's the same as frontwards distribution. We're taking this 3x to the fifth and we're multiplying it by negative 2x y to the third. I'm going to write that out as negative 2x y to the third multiplied by 3x to the fifth. And then I'm also distributing the 3x to the fifth to the negative 6x squared. So that's minus 6x squared times 3x to the fifth. Those are my two terms right now. All right, so let's focus on multiplying this together. I'm going to follow the directions that I suggested, right? Let's multiply the coefficients. So negative 2 and 3 are my coefficients. If I multiply them, I get negative 6. And then let's add the exponents. Now the key is we're going to add exponents on the similar variables. So I have x to the first times x to the fifth. If I add those exponents, 1 plus 5 makes x to the sixth. And then I still have a y cubed. I don't add that exponent to anything because it's a y for the base, so it can't be combined with the other variables. So that negative 2x y cubed times 3x to the fifth is negative 6x to the sixth, y to the sixth. And then let's go ahead and address this second term here by doing the same thing. We're going to multiply the coefficients, so negative 6 times 3 is negative 18. And then x squared times x to the fifth, we're going to add the exponents on the variables. So we get x to the seventh. And the problems do get a little bit more complicated as we start seeing more than just a monomial multiplied by a polynomial. So monomial meaning one term. In this, we're going to be multiplying a binomial, two terms, by another binomial, two terms. So we'll get some double distribution going here. Okay, the first thing we want to do is we want to distribute this x to both terms in the second parentheses. So we're going to do x times x, that's x squared, and then x times 3, which is 3x. So plus 3x. Then we can go ahead and distribute the 2. 2 times x is 2x. 2 times 3 is 6. Last but not least, after I've finished distributing both terms in the first parentheses to all the terms in the second parentheses, we're going to go ahead and combine like terms. So the terms that I see that are like are the 3x and the 2x. When I add 3x plus 2x, I get 5x. So I'm going to just bring down the x squared. In the middle is the plus 5x, and on the end is plus 6. Let's see if there's any more complicated ones that make this. Ooh, number 4, that looks really tough to me. I've got 2 different letters in there and then lots of different coefficients. So let's see what it looks like when we multiply these binomials to each other. First, I'm going to follow the exact same process that I did for the other problem. I want to distribute both terms in the first parentheses to both terms in the second parentheses. So let's start with this 3r. We're going to multiply 3r by 4s. We follow the same process. Multiply the coefficients. 3 times 4 is 12. R times s is just rs. So 3r times 4s is 12rs. Then distribute the 3r to the 2r. 3 times 2 is positive 6. R times r is r squared. All right, we're done distributing 3r, so we'll move on to 9s. 9s times 4s, multiply the coefficients, 9 times 4 is 36. S times s makes x squared. And then distribute 9s to 2r. 9 times 2 is positive 18. S times r makes SR. Last but not least, just like on the other problems, we're going to look for any like terms. So I'm going to look and see, are there any other terms that have an RS in them? This term has r squared, this term has s squared, this term has SR. The order is different, but it's the exact same variables. So 12RS and 18SR are considered like terms, and I can put them together. 12 plus 18 makes 30. And I like to put the letters in alphabetical order, so I'm going to write it as RS. You can write it as SR. It really does not matter. So those two terms get put together, and then we're going to go ahead and add the 6R squared and the 36s squared. And that is all for multiplying polynomials. I hope you enjoyed this video.